This video will hopefully give you a quick recap on logarithms. They're a fantastic connection between exponentials, really. And if we look at this, we can have a log of any base, because basically we're looking at this base here to the what power gives me a. So this is how we end up with the relationship of log base b to a certain power c will give me the answer a. It seems a bit funky, but when we put it into practice, all this is saying is 2 to the power of 3 gives me 8. Okay, so log base 2 of 8 equals 3, since 2 cubed equals 8. Okay, now log 10 base 10 of 100 equals 2, because 10 squared equals 100. Now we're going to deal mainly with log base 10. I know up here we said, we can change the logarithms and the bases and all that sort of stuff, but we're just going to stick with log base 10, and it's so common that we don't have to keep writing the base 10. If there isn't a base written, we assume that it's base 10. Okay, so with this one, we can work this out without going to the calculator. We can just say, well, this is log, now 1,000 is 10 cubed, so therefore log of 10 cubed, that is just 3, because we've got base 10. Okay, and again here there's no base, so we assume it's 10, so I'm going to express this as 10. Remember, square root of something, that's 10 to the half. So this is a great topic to also remind you of your exponential rules, and so log of 10 to the half, that would actually be 1/2. We can check that, but I'm not telling you porky pies over here. So if we go log 100, you can see that it is 2, because 10 squared is 100. Okay, we do log, we just did root 10. We said that was 1/2, and correct. All right. The reason that we're doing logarithms is it's going to help us solve equations when we do not know the power. So in order to do that, there's some great little rules, some relationships between logs. And we've got our first one here, which is log a plus log b equals log ab. Right? Really straightforward. So if we look back to our calculator, if we say something like log 2 plus log 3, right, what we're saying is that this should be the same as log 6. And it is. They're exactly the same, because 2 3s are 6. And as you can see, log of a number, it's just a long-winded number. Okay, it just keeps going on and on. So we would rather say something like log 5 instead of the decimal that it is. Now similarly, the other rule, log a take log b, we can simplify to be a on b. This is the rule that we're going to use over and over to help us solve. This is the most important one, I believe. So if we've got log of something to a power, we're allowed to bring that power downstairs and take log of the a. A couple of things to realize is that we cannot take log of a negative number, or in fact of 0. So if we go back over here, if I say log of 0, we'll get error. And if I say log of a negative number, log of a negative number, that's no good either. So it has to be positive. And one of the things that you're going to be asked to do is to just fool around with these rules to help you simplify expressions. So for this one, we can see very clearly we've got log a plus log b, so we follow this rule and we can say, well, that's simply 5 times 8, that simplifies to log 40. That's all we have to do. With this one, we say log 30 take 6, so we're looking at this rule here, divide them, so this becomes log 30 over 6, which is also known as log 5. All right, you can pop that into your calculator, put this and then put this, and you'll see that you get the same answer. Now we can take that up a little bit, and we can look at something like this one. Okay, so it's a little bit more complicated. And the first thing we do is, when you've got the power out the front here, or the number out the front, we're going to use this rule and go backwards. So I can now say that this will be the same as log 2 cubed plus log 5 take log 4. Now 2 cubed is 8, so we've got log 8 plus log 5. Now I'm going to use this rule here, that when I've got a log A plus log B, you times them together. So I can say that's log 8 times 5, and I've still got my take log 4. Now log 8 times 5 is 40. We take the log 4. So now I can apply this rule here, and that means that I can divide them. So 40 divided by 4 is log 10. And remember, that's 10 to the 1, and it's base 10 because there's no base written there. We can assume it's 10. It actually is just 1. Once again, you can go and check that, pop that into your calculator if you so desire. So now we want to get to the main purpose of logarithms, and it allows us to solve questions like, if I've got 2 to the x equals, I don't know, let's go with 7, okay? In the past, you were able to solve expressions like 2 to the x equals 8 because we knew that 8 was 2 cubed. So getting them into the same base, we could then say, well, if the bases equal each other, the powers have to equal each other. So x was 3, and that was straightforward. And, we made them a little bit more complicated, but getting them into the same base was our tactic. With this, we obviously cannot get 7 as a base of 2. So this is when we use our logarithm law, the one that I said was really important, right? So log a to the n equals n log a. What this allows us to do is bring our power downstairs so we can now play with it. When it's unknown and it's upstairs, we can't really do much with it. So what I'm going to do, good old maths, what you do to one side, we do to the other. So I'm going to log both sides. And once I've done that, I can now apply this rule here. So the x comes downstairs, so it's x log 2 equals log 7. And therefore, there's a times in between, and we know that to get rid of a times, we divide. So that becomes log 7 divided by log 2. We go to our calculator. We can pop that in. Log 7 divided by log 2, we get let's go with 3 decimal places, 2.807. So x equals 2.807. Now to check that we're right, let's pop that back into over here. So 2 to the, and I'm going to use my answer key instead of writing 2.807. And you can see that I do indeed get 7, okay? So that's the main reason for logarithms. We can pop that into real life situations to help us. Now we can take it up a little bit of a notch and solve something like this. So once again, I can't use any of my linear or quadratic tools to try and solve this because the unknown is a power. We can't log right at this point in time because we've got this times 19. So we first have to get rid of this times 19. I mean, you could log, but it would be uglier. So what we're going to do is get rid of the times 19. We will divide the other side. And I'm not going to go to my calculator to work that out. I'm just going to use my calculator right at the end. So we just keep it like that, okay? It's a number, just like the other one we did, that it was simple, like just 7, but that's just a number. So what do we do now? We log both sides, right? What you do to one side, we do to the other. That's nothing new. And now here comes our new bit. And I wrote that just a little bit funny there. It wasn't 3 to the x, it was just 3x. Right, sorry about that, that was a log 11 to the 3x. Now we can use our rule that this 3x comes out the front. So it's 3x log 11. So 3 times x times log 11. Remember, log 11 is just another number. And so here we want to get x by itself. So remember what we just said was it's 3 times x times log 11. Remember, we can multiply in any order, so that is the same as x times 3 times log 11, which I can write as just 3 log 11. So to get rid of that times 3 log 11, I can just divide. So we go log 320 over 19 all over 3 log 11. I have not used my calculator at all, right? Keep it all in one step. Now we go to our calculator and we can suss it, and we've got beautiful fraction buttons. So we've got our fraction, log fraction was 320 over 19, I think, over log 11, 1.178, 1.178, and again you could pop it back up here to check that you were right before you move on to the next. So it was 19 times 11 to the 3 times. Now again, I'll use my answer key. If I actually did use 1.178, I would get an answer a little bit over 320 because I'm rounding up. But luckily for our calculators, it's all in here. Ooh, so that doesn't look good. Okay, so you don't go on to the next question. You go, what did I do wrong? And go back, and you can see very clearly that you wasn't just dividing by log 11, it was dividing by 3 log 11. This shows you that you always need to make sure that you go back and check that your answer is right. It doesn't take long, and you can find an error pretty quickly. So pop the 3 there, and you can see now it works out beautifully. So make sure you go back 0.393. You must always check that your answer is reasonable, and we do that simply by substituting back in. Okay, so you can go back to your revision and do some of those questions. Hopefully that helps you a little bit with logs.